Hey everyone, and welcome to Mr. Ahmed's Math 20 Chapter 3.4 screencast. Today we're talking about volume and capacity of spheres, cones, and pyramids. So getting started, so right off the bat, here is the formula for a sphere, for the volume of a sphere, and that's 4/3 times pi times r cubed. You could also think of this formula as just being 4 times pi times r cubed, and then all of that divided by 3. Okay. So, for example, if you are looking to find the volume of a sphere and you're given the radius, you would simply use this formula and input the value for the radius where it says r. A reminder from our previous subtopics that 1,000 centimeters cubed equals 1 liter of capacity. So a volume of 1,000 centimeters cubed equals 1 liter of capacity. Your workbook also tells you that you'll also need to know how to convert between cubic meters and cubic centimeters. So just so you're aware, I know some of you are inclined to be like, oh, well, 1 cubic meter is therefore 100 cubic centimeters because there's 1 meter, in 1 meter there's 100 centimeters. That's not the right way to look at it. And they actually do the example out for you. A box with dimensions 1 meter by 1 meter by 1 meter would have a volume of 1 meter cubed, because height times width times depth. However, a box that is still 1 meter, except you write it out as centimeters, so instead of saying 1 meter, you've now got 100 centimeters. Well, 100 centimeters times 100 centimeters times 100 centimeters gives you 1 million centimeters cubed. And so your workbook actually tells you 1 meter cubed is equal to 1 million centimeter cubed. So moving right on to example 1, a spherical exercise ball has a diameter of 1.2 meters. What is its volume? To determine its volume, you're using the volume of a sphere formula. Please be sure to tune into the keywords. Here it tells you that the diameter is 1.2. So you have to actually understand that this is a diameter and that the diameter is twice the radius. So if you're going to go and figure out what the radius is, you've actually got to take that diameter and divide it by 2, and that's what you get here, 0.6 meters. So you simply plug it into the formula, 0.6, and then to the power 3 times pi times 4 over 3, and you get a volume of 0.904779 meters cubed. Now it's asking you, what is its capacity? You'll have to take this meter cubed and change it into centimeters cubed. You can do this, if you're not too sure how, you can do this using the proportions method. So you can be like, if 1 meter is equal to 1 million centimeters cubed, then 0.904779 meters cubed is equal to how many centimeters cubed. And as you can see, you will end up having to take this meter cubed volume and multiplying it by the centimeters cubed to get how many centimeters cubed that is. So that's 904,779. And then you'll remember that 1 liter is 1,000 centimeters cubed, so therefore 905,000 is therefore 905 liters if 1,000 is 1 liter. And again, you can set up your proportions here. You can say, so 1 liter over 1,000 centimeters equals how many liters over 904,779 centimeters cubed. Okay. At this point, you can pause the video and attempt the Build Your Skills questions on this page. Okay, so moving on to working with volumes and capacity of pyramids. The volume of a pyramid, and actually the volume of a cone, is actually the area of the base times the height, and then divided by 3. Now, I know this says multiplied by 1/3, but I'll have you remember again that it's when you multiply by 1/3, it's the same thing as dividing by 3. Okay, so that is actually the formula for the volume of a pyramid, as well as cones actually. Okay, so the area of the base times the height of the pyramid or the cone, and then divided by 3. Okay, so moving right on to example 2, calculate the volume and capacity of this pyramid. So again, we said the area of the base, so you would go 18 times 15. So open up my calculator and do that. So 18 times 15, that's the area of the base, and then times the height, which in this case is 25 centimeters, so times 25, and then divided by 3. So you should be getting 2,250 centimeters cubed. Okay, so there you go. I think the question was also asking you what is the capacity, and once again you can set up your proportions. If 1 liter is equal to 1,000 centimeters cubed, then how many liters is 2,250 centimeters cubed? So you're going to take 2,250, multiply it by 1, divided by 1,000 to get this up here, so cross multiplying. So 2,250 divided by 1,000, and you get 2.25 liters. Okay. At this point, you can pause the video and attempt the Build Your Skills questions on page 186. Okay, so moving on to example 3. Calculate the volume of this pyramid. Again, it's the same formula, base times height, and then divided by 3. So area of the base times height divided by 3. Except that here we don't have the height. We do, however, have the slant length. So this is the slant length right here, 22 centimeters. But we don't have this height right here. And actually, as you can tell from this, there's even a right angle right here. As you can tell, we've got a right angle triangle shape right here. Okay, so you're actually going to use this slant length, which is starting to look like the hypotenuse of this triangle. So you're using the hypotenuse of this triangle and the base of this right angle triangle to figure out this side right here. Okay, so this side right here is actually the length of your it's the height of your pyramid. Okay, and this is actually one of the side lengths of your right angle triangle. So what you're going to do, you're probably cluing into this. You're like, hypotenuse and length of a side. Oh, hey, that's the Pythagorean theorem. And that's right. So you are going to be using the Pythagorean theorem to figure out the height of this pyramid. So you got to take a look at this side down here, and you're going to notice that this side down here is actually half of this entire side right here. Okay, meaning that this side down here is actually 13 centimeters. Okay, so this side is 13 centimeters, which is half of this right here. The hypotenuse is 22 centimeters, and then you can figure out the actual height. So it is the formula for the Pythagorean theorem is a squared plus b squared equals c squared. So then that means to me that I've got to take c squared, subtract it from b squared to get a squared. So 22 squared gives me 484, and that minus 13 squared gives me 315. And then I've got to square root that to get the actual length of this side. So square root that, and I get 17.748. Okay, so that would be the height of my pyramid. And I'm sure that that's what they went and got first. So here you go, they got that first. And then now it's just a simple matter of going area of the base times the height divided by 3. So height, and then times the area of the base, and then divided by 3. So times area of the base is 26 times 18. Close my bracket there. And then that divided by 3. So I got 2,768.73. So they went and got 2,761.2. And the reason that our values are so, well, not that different, but the reason that why my value is actually the better value is because I went and used the exact value for the height. So we had figured out that the height was the square root of 315, which was 17.748239, and I actually went and used that exact value and multiplied it by the height of the pyramid, and then, no, sorry, this is the height of the pyramid, so I actually took this height of the pyramid, multiplied it by the area of the base of the pyramid, and then divided it by 3. So my answer was actually very, very precise and very accurate because of the fact that I had not rounded. But as you can see here, they actually did go and round early on, and then that gave them a value that's quite off actually. uh, especially if this were like a numeric response question. Um, you would want to use the exact value. So I would recommend that you not round up or down early on in your formula or in your process, because then by using a rounded value with your actual formula, that can throw off your answer. So the right answer here was 2,768.7, which you can round up to 2,769. Okay. So at this point, you can pause the video and try out the Build Your Skills questions on page 188. Okay, so now moving on to volume and capacity of cones. The formula for the pyramids, for the volume of a pyramid, is still the same for the volume of a cone. It's still the area of the base times the height divided by 3. The only difference here is that the area of a base, because this is a cone, the area of a base is actually the area of a circle. And that's because a cone's base is a circle. So you, instead of using length times width, as we had used with a pyramid, because we are now dealing with a cone where the area of the base of a cone is a circle, so therefore the area is pi times r squared. And that's it, really. So you find the area of the base, which is a circle, you multiply it by the height, and then you divide it by 3. So here they're telling you a paper cup in the shape of a cone has a radius of 3.2 centimeters and a height of 6 centimeters. How much water can the cup hold? So it is asking you for capacity, right? So it's asking you to, well, you've got to figure out the volume first, and then it's asking you for the capacity of this paper cup. So what we are going to do, just give me 1 second here. Okay, so you're going to figure out the area of the base first and then multiply it by the height. So the area of the base is the circle, and here's the radius of the circle. So 3.2 squared, so that's radius squared, times pi. There's my pi button. Okay, so here's the area of my base, and then I multiply that by the height, which is 6 centimeters, and then divide that by 3. So I got a volume of 64.3398, and that's in centimeters cubed. And then if it's asking for the capacity, just again, a reminder that 1,000 centimeters cubed is 1 liter. Therefore, how many liters is this? So I'm actually going to take that and divide it by 1,000, and that gives me this answer right here. So first of all, here was my the volume, so 64.3, and that's what they wrote here. So that is the answer in terms of just the volume. But to convert it to capacity, I took that and divided it by 1,000, and I got 0.064 liters. And 0.064 liters is indeed 64.3 milliliters. Okay, so there you go. At this point, you can pause the video and attempt the Build Your Skills questions on page 191 of your workbook. Okay, and by now you'll realize as well that that was the end of the subtopic. So I would advise you to do the Practice Your New Skills questions on page 192 of your workbook. And as well, because this was the last topic of the chapter, there's also a chapter test at the end of this topic. So I would highly advise you to accomplish these questions, the chapter test questions, on page 194 of your workbook as well. Okay. Otherwise, that's it. Stay tuned for chapter 4 material.